Welcome to a tutorial of Proflearn YouTube channel. In this particular video, we're going to have a discussion on electricity, and we're going to look at how you're supposed to approach each and every question that you are given for IGCSE Physics. The first question here, we are supposed to work out the total EMF, and we are told the battery consists of 4 cells, because in an exam you may be asked to state what we mean by EMF, what we mean by potential difference. I'm going to look at that in a short while. So in this case, we are given a battery, and the battery consists of 4 cells, and each of the cell has an EMF of 1.2, and we are told that they are connected in series. So if they are connected in series, you are going to take the number of the cells times the EMF of each of the cell, and that's going to translate to a value which is equivalent to 4.8 volts. Then we are supposed to work out the total resistance of this connection, whereby you can see we are told each of the resistor is having 12 ohms. So which means on this case here, we are having these two resistors. These two resistors here are going to combine. We're going to add them, 12 plus 12, that will be 24. So these two resistors can be combined to be one resistor, which is 24 ohms. Then once we have done that, then we shall have these two resistors which will become one. Then it will be in parallel with this other one. So that's why you can see that when I was working out this question, I said 12 plus 12, which is going to give us 24. So this can be replaced with one resistor of 24 ohms. Then when two resistors are connected in parallel, anytime you have a resistor connected in parallel, resistors connected in parallel, so the total resistance is going to be 1 over 1 of the resistor plus 1 over the second resistor, depending on the number that you have. Then you close the bracket raised to power -1, which you can put direct in your calculator, so that you get the answer direct. So in that case, I said now, since these two are going to combine and becomes 24 ohms, then I can say 1 over 12 plus 1 over 24 raised to power -1, that is going to give me 8 ohms. But now when I've worked out this combination, it's in series with this other resistor that we have here, which is also 12 ohms. So meaning we're going to get the total resistance by saying this value that we have gotten here plus 12, and that's going to give us 20 ohms at that given point. So at this point, if you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. And also consider joining our Patreon page, where you can be able to access the PDF of this worksheet, and also the PDF of our solutions. So now let's go straight and work out in this particular question, and we are told that calculate the reading on the voltmeter. So meaning whatever that we are trying to do here is to work out, we want to work out the voltage. So how do you work out the voltage when you have a voltmeter connected at this given point? So something that you need to remember here is that we must work out the total current that is flowing in this circuit. And the total current is going to be the total EMF divided by the total resistance. So we have gotten our total resistance here, and we had gotten the EMF, which was 4.8. Then if you work out, we're going to get the total current that is flowing in this circuit is 0.24. So meaning that the current that is passing here is 0.24. Then we know that V is equals to IR from Ohm's law. So meaning that if we take the resistance here times the current that is flowing here, we are going to get the total voltage, and that's going to be 2.88, approximately 2.9 volts. The next question that we have here, we are told that the diagram shows an electric circuit which includes an insulated resistance wire XY. A teacher shows some students how to complete the circuit by placing the contact C at various positions along this wire that we have here. Then calculate the reading on the ammeter when contact is at X. When this wire is in contact at X, the only part that is having resistance, the resistance that we're going to have in place here is 8.0. So if we want to work out the current that is flowing, we're going to use the voltage divided by the resistance, which is 8, and that is going to give us 0.75 amperes. Yeah, because when this contact C is at this point, this resistant wire has no impact in this particular circuit that we are having at that given point. So once we have identified that, we are going to, the student move contact C to point P. The resistance of the wire between X and P is 20 ohms. So if we are told that the resistance between this point here is 20 ohms, is basically like we are having a resistor at this point. So this resistor and this one here is, the two are in series. So if we want to get the total resistance, we're going to say R1 plus R2, and that's going 20 plus 8, which is going to translate to 28 ohms. This becomes 28 ohms. Question number 3, we're told the diagram shows a kitchen tap that supplied instant boiling water. Cold water passes over the electric immersion heater inside the tap. The boiling point of water is 100 degrees Celsius. Then we are told the immersion heater is powered by the mains at a voltage of 330. When the tap is open, the heater switches on and the current is 13 amperes. Then we are supposed to work out the thermal energy produced by the heater in the next 60 seconds. And remember, we're going to use the concept of thermal energy is equals to MC change in theta, mass times specific heat capacity times temperature change. And in this case, you need to understand how to define specific capacity, because specific capacity is the amount of thermal energy required to change a temperature of 1 kg of a substance by 1 degree Celsius. So you need to remember that, so that when you are asked during the exam, you can be able to answer that to avoid crying after the exam. So if you work it out, 13, which is the current, times the voltage, which is 230, times 60, you are going to get 1.8 times 10 raised to the power 5 joules of thermal energy. We are told the specific capacity of water is 4,200 joules per kg per degree Celsius. Cold water enters at which temperature? 22 degrees Celsius. So if we want to work out the temperature change, because this water is going to boil, it will be 100 minus 22, which is going to be 78 degrees Celsius. So if we are having 78 degrees Celsius in this case, we can be able to substitute to thermal energy is equals to MC change in theta. But the energy that is going to be absorbed is basically the thermal energy from the heater that we are having at this given point. So because we don't know the mass of water involved in that is going to flow for 60 seconds, we are going to say thermal energy that is supplied is absorbed by the water that passes through. Right? That's the assumption we're going to take. So we are going to say E equals to MC change in theta, and if we make M the subject, we're going to have thermal energy, and our thermal energy is this of specific capacity times the temperature change, which we have gotten at this point. So if we work it out, we are going to get the mass to be 0.549 kilograms, because we are calculating the rate at which water at boiling is going to emerge from the tap. We are going to say now, therefore, that rate is going to be the mass. Rate is going to be the mass divided by the time taken. And if we substitute, we're going to get 9.16 times 10 raised to the power -3 as our final answer, like that. So we are going now to move to the next part, whereby we are given more of circuits, and we need to calculate the power of the heater. So something that we need to understand is that power is equals to IV. This one, I don't want to have it at this point here first. Let's say power is equals to IV, and then we can be able to say current equals to voltage over resistance, because V is equals to IR. Now, the heater has a resistance of 22 ohms and the PD across it is 45. So if you have the voltage and you have the resistance, you can be able to work out the current that is passing through this particular heater that we are having here. So which means if we take 45 divided by 22.5, we are going to have our current to be 2 amperes. Then how do we work out power? Power is current times voltage. So current times the voltage is going to give us what? 90 watts. 90 watts is the power of this heater. What is the potential difference across resistor X? Now at this particular point, I said I'll mention how to define potential difference, and EMF. When you are going to be asked a question to define potential difference, you are going to say potential difference is the amount of work done or the energy supplied to move a unit charge between 2 points in a circuit, or across 2 points in a circuit. But if you are going to be asked to define EMF of a cell, we are going to say EMF is the amount of work done to move a unit charge around a complete circuit, so that you can be able to earn your mark. If they are asking you differences, you will give those two differences I've mentioned. But if they're asking you similarities, you will talk of both of them are measured in volts, both of them are measured using a voltmeter, both of them measure the energy per unit charge, right? So if you have gotten value on that, and if you have not subscribed, subscribe so that we can be able now to go through this. And I can see here they are asking us the PD across resistor X, the PD potential drop across resistor X. We have been told that the PD across the heater is 45 volts, but you need to remember the PD across here plus the PD across this must give us the EMF, which was 60 volts, right? The PD across this plus the PD across this will give us 60. So which means for us to get the PD across X, and also I need to mention that the PD across 10 and X are the same, because these two components are parallel. So we are going to say PD across X will be 60 minus 45, so meaning across X we shall have 15, and also this will be having 15. The current across the 10 ohm resistor, because the 10 ohm resistor also will have a voltage of 15 volts. Then the resistance here is 10. Then we're going to say therefore the current is going to be 15 divided by 10, and that's going to be 1.5 amperes as the answer in that case. A student connects the circuit shown in the diagram. The value of the fixed resistor is 20 ohms. The switch is closed. The reading on the ammeter is 0.3 amperes. So the reading here is 0.3 amperes. Calculate the potential difference across the fixed resistor. So if we are having a reading of 0.3 amperes, it means that also the current that is passing through this circuit, because it's a series circuit, the current that is passing through here is basically the same, which is 0.3. So which means current that passes through this fixed resistor is also 0.3, and that means now if we want to work out this PD across this, we need to say V is equals to IR. So it will be current, which is 0.3 0.3 times the resistance that we are having here, so that we can be able to get our answer. So that becomes what? 0.3 times 20, which becomes 6 volts. State the name of the device to measure potential difference, that is a voltmeter. Show how the student connect the device stated in B to measure the PD across the fixed resistor. So remember, a voltmeter should be connected parallel to any electrical device. So we're going to connect our voltmeter here, and it's going to be measuring this voltage PD across this 20 ohm resistor, right? Then next part is a question on a DC electric motor, and the way a DC electric motor works. Actually, I need to give an explanation. Of course, we are going to have another tutorial on electromagnetic induction. So, but let me just explain exactly what's happening in this case. Remember the two permanent magnets that we are having here. The permanent magnets that we are having at this given point here. Let me just show you. The permanent magnets that we are having at this point here, they have magnetic fields. The two permanent magnets have magnetic fields. So since there are magnetic fields between these two permanent magnets, then when current flows through the coil, remember, when current passes through the coil, what happens? When current passes through this coil, what happens? Magnetic fields will be created around that coil. When current flows through a conductor, magnetic field will be created around this conductor. And since there are magnetic fields on between these two magnets, magnetic field due to the permanent magnet, then the fields of the permanent magnet and the fields due to the current that is flowing through the wire are going to interact. And when the fields of the permanent magnet and the fields of the conductor due to the flowing current interact, there is a force experienced on this coil, and this coil is going to experience a force, and one part will experience a downward force and another part will experience an upward force, according to Fleming's left hand rule. Because if you hold your fingers mutually at 90 degrees to each other, the first finger point to the direction of the field, this point to the direction of the current, and the thumb points the direction of motion. So on the diagram, draw a pair of arrows to show which coil rotates, how the coil rotates. This coil is going to rotate anti-clockwise because one part is going to experience a downward force and the other part is going to experience an upward force shown there. Right? So this part that is next to the North Pole is going to experience a downward force according to Fleming's left-hand rule, and the other part of the wire which is next to the South Pole is going to experience an upward force like that. That is well displayed there, right? According to Fleming's left-hand rule. So you need also to understand the uses of the brushes, the spritlings. Of course, the spritlings are there so that the coil can be able to rotate in the same, continuously in the same direction, or to reverse the current, after one complete turn. Okay, let's explain why electrons flow in the direction as shown. Of course, electrons usually flow from the negative to the negative terminal, from the negative terminal to the positive. And in that case, the reason as to why electrons flow like that is because electrons are usually negatively charged, so they are going to be repelled by the negative terminal and they are attracted to the positive terminal of the source or the power supply. A teacher is investigating the resistance of a lamp, and then we have a circuit here. To determine the resistance of the lamp, the teacher adds 2 meters on the circuit. Draw the circuit symbol to show the meter correctly. So the first meter was to measure voltage across the lamp, because if we are investigating the lamp, we are going to measure the voltage across the lamp, and also we shall measure the current in the circuit, and we have a variable resistor which is going to vary the resistance in the circuit. So whenever you are connecting a voltmeter, you should connect it parallel to the component, but an ammeter is connected in series as shown there. And we are asked to state the name of X. X is a variable resistor, and then we were to describe how the teacher uses the component X to investigate the resistance. So the component X is going to be used to vary the resistance of the circuit. So because a variable resistor or a rheostat has some knob which you adjust or you slide to change the resistance. Once you change the resistance, the values of V and the value of A will change. Then you can be able to record that. Remember, resistance is equals to V over I, voltage divided by current. So you can be able to work out the resistance using this formula, or you can get more values of V and more values of I. Then you plot a graph of V against I, and the gradient of that graph is going to give us what? Is going to give us the resistance. Then we move to question number 8. Question number 8 was on charges. So something that you need to understand: when materials are wrapped, due to friction, charge is going to be transferred. And in this case, we have two charges, positive and negative charges, and you need to understand the law of electrostatics, that unlike charges attract, like charges repel. And then we are told that the diagram shows two spheres. One of the spheres is negatively charged, and we can see this is the one that is negatively charged, and we have sphere S which doesn't have any charge, so meaning it has equal positive and negative charges. And when it's brought next to a negatively charged sphere, it means electrons, the negative charges will be repelled, so they will go on the other side, and the positive charge will come to the side, they will be attracted. So that's why in A you were supposed to state what happens to the distribution. We shall say S will be attracted to the negatively charged sphere. Of course, it will be attracted because this is a positive, this is negative. And you are also supposed to draw the distribution of the charges which have indicated that given point. An earth is then touched again. So meaning that if an earth is connected to the ground, so what is going to happen here is that we have an earth running to the ground. So if we are having an earth which is running to the ground, then it means electrons will flow, will move to the wire towards the ground, yeah, and this sphere is going to remain positively charged. So something that you need also to remember is that only electrons are free to move. Positive charges don't flow. So if this was positively charged, electrons will flow from the ground to neutralize. But if we are having negative charges, they will flow to the ground, and this is going to remain positively charged. In question number 9, we are told the diagram shows a circuit used by a student to test a metal wire made of nichrome. State the name of component Z. Component Z is a variable resistor or a rheostat, and the current reading on ammeter X is 0.8 amperes. So in this particular case, let us look at this. So at this particular point, let me just take you back to the question. We are told that the diagram shows a circuit used by a student to test the metal wire made from a nichrome, and then we are given the setup whereby we can be able to see there is a current flowing through this ammeter of 0.8 amperes. We have component Z, which is a variable resistor, and then we have a voltage. This voltage is basically measuring the voltage of the nichrome wire. So the current reading on the ammeter X is 0. Stay the reading on ammeter Y. Because this is a series circuit, it means the current that is flowing here is the same current flowing in this particular circuit. So which means the current that is flowing through Y is also 0.8 amperes. Current in the nichrome wire is 0.8 amperes. Already we have mentioned that. And the potential difference across the nichrome wire is 4.5. Calculate the resistance of the nichrome wire. Yeah, so how will we work out the resistance of the nichrome wire? So remember, we have the formula V is equals to IR. So which means that using this formula here, V is equals to IR, we can be able to say 4.5 divided by 0.8, which is going to give us 5.625. With this, we can be able to round it to 5.6 ohms as the resistance. A student tests a different nichrome wire which is thicker than the wire in C. If the wire is thicker, this means there are more electrons in the cross-section area which can be able to transmit electricity. So which means the resistance of the wire is going to decrease. More current is going to flow. So a thicker wire has low resistance, so current increases in this particular circuit. A cylindrical metal wire W of length L and cross-section area A has a resistance of 16 ohms. A second cylindrical wire W has length which is a half the initial one. So remember, the longer the wire, the greater the resistance. So if this wire has L which is a half the initial, also the resistance of this wire is going to decrease by a half. So we are going to have 16 divided by 2 as the resistance of wire 2. And also we are told the cross-section area is 2A, twice A. So meaning also resistance is going to decrease by 2, by a half, right? So we are going to have the total resistance becoming 4.0, because that is 16 divided by 2, which becomes 8. And this is going also, this can be written as, of course, this can be written as 16, which can be written 16 times 1/4, and the final answer becomes 4 at that given point. Then the effective resistance of W1 and W are then connected in parallel. I told you when two components are connected in parallel, resistors are connected in parallel, so you are gonna say 1/R plus 1/R2 raised to power -1, so that you can get the answer direct. 1/16 plus 1/4 raised to power -1 raised to power -1. Then if you work it out, you're going to get 3.2 as the answer. And we have another question here whereby we are told that the parallel pair of resistors are connected to a battery that is made from 3 cells, and each of the cells has an EMF. Each of the cell has an EMF of E, and these cells are connected in series. So what's the total EMF? It will be 3 times E. So if you have not subscribed to Proflearn, consider subscribing, so that anytime I'm going to do more tutorials, because we are going to have another live on electromagnetic induction, so that you can be able also to see how do you answer question to do electromagnetic induction. That will be the live that we're gonna do tomorrow. So purpose to join me at a time like this tomorrow, so that we can be able to do more on that. So this given point,